Now let us discuss about the final content from unit number 2, that is what is the post processing techniques, support removal, surface finishing, and heat treatment. Now support removal, once the part is printed, we are if the support structure is there for printing, so we have to remove it using certain tools. Okay, so there are two techniques are there. One is the manual removal. For this we are using different types of tools such as the pliers, cutters, tweezers, or utility knives. So we have to carefully break away the support starting from one edge and working your way around. Okay. So likewise, we have to remove the supports using the tools. Simple and low cost. This is the simple and low cost method, but it is a time consuming and sometimes it may leave mark or require further finishing. Okay. So that is using the manual removal. For that purpose, the tools are available. Okay. Or we can purchase it along with the 3D printer. The second method is the soluble supports. For this purpose, the PVA, that is polyvinyl the alcohol, there is a separate filament is there. That means one filament it is used for building the parts, and the other filament it is used for building the supports. So for this, when you are using polyvinyl alcohol, so if you dissolve that in the water, so it is a soluble and it get removed. Okay. The another method is the sanding. Okay. So using the sandpaper, you can remove the supports. Okay. So that is the soluble supports are there. These soluble supports and the sanding. So these are the methods for removing the supports that are there on the 3D printed parts. Then we have discussed about the soluble supports. If you dip that the 3D printed part into the solution or water, limonene solution or the water, so the support get removed. Okay, or the support get dissolved, and the only the 3D printed parts remain there. Okay, so that is the soluble supports are there. Then after that, this is the surface finishing. Now, once the supports are removed, we have to provide the surface finishing. So for that purpose, we can use sanding, sandpaper to smooth the surface, filing, the use of file to remove the larger material excess material, polishing. You can provide the polishing using to have a glossy finish. Painting, you can apply the paint to color or protect the object, and you can also do the chemical etching or laser engraving. So if you see, the initial material is something like this, and after polishing it looks something like this. Okay, so these are the painting, glossy finish. So for this part, now this is the surface finish. Okay, so this comes under the surface finish. So these are the techniques that are used for the surface finishing. Now heat treatment. Now some 3D printed parts, they require heat treatments to provide the strength, durability, and other properties to the printed object. So these are the heat treatment processes like annealing. So for this PLA, ABS, and other thermoplastic, we can put that into the oven for a certain time with a desired temperature, and we can provide the heat treatment to that particular 3D printed object. Okay. The another advantage of the providing the heat treatment to the 3D printed part is to remove the stress. When we provide the heat treatment to this 3D printed the parts, so at certain temperature, so it relieves the internal stresses from the 3D printed part. Now, if you see the advantage of this heat treatment, so if the part is not treated, so it is having the strength of 17.9 megapascal. So this is from one journal paper, and if it is when it is heat treated, so its strength increases, compressive strength increases to 101.9 megapascal. Okay, so these are the advantages of the heat treatment. Now after that, once now the part is ready with you after post processing, now we have to carry out the quality control and inspection. Now these are essentially ensuring that the 3D printed parts meet the desired specification and performance standards. Implementing a comprehensive quality control process helps identifying defects early, ensuring consistency and reliability in production. Now design verification. So in quality control, you have to verify the CAD model to ensure it is accurate and complete, checking for errors and that could be affect the print. So this we can do in the earlier stage only, CAD model inspection. So, and we can also perform the simulation. The simulation will help us to the predict the issues like warping, shrinkage, and supports and requirement. So simulation we can do using the simulation software like CAD, CAE, then the other simulation software you can use also. Then material quality control. So which type of material which we are using for our 3D printing, that we have to decide earlier. For that purpose, you have to check the certification to ensure the filament or resin meets specified standards and comes from a reliable supplier. Okay, because so many suppliers are available in the market, so you have to check the certification for your the filament, that is material. And storage. So once you purchase the material, so store it the storage is very important, because the long use of this, if you are not using this filament for a long time, so it may damage your filament. Okay, so you have to keep it in dry boxes or desiccant packs for the filament, or you have to use the desiccant packs. Then printer calibration and maintenance. We have already checked we have to check the printer in quality control. You have to check the printer, and you have to calibrate the printer. So we have seen the different types of the calibration: weight leveling, extruder calibration, verifying nozzle diameter. Okay, then dimension accuracy calibration. Okay, so many types of calibration we have seen. So that is required. Now follow a maintenance schedule for cleaning and replacing own parts like nozzle, belts, and fans. So that that comes under the quality control and inspection. Then the next one is the process monitoring. Now real-time monitoring, using the camera sensors to monitor the printing process, detecting the issues such as layer shifting, nozzle clogs, and print bed addition. So that is possible now nowadays using the IoT, Internet of Things. Environmental control, control the printing environment to minimize the effect of the temperature and humidity variation. So you must keep the printer in such environment so that this environmental there should not be any environmental effect on the 3D printing process. Then post-processing inspection. After this, you have to check the final product. It should undergo a thorough visual check to identify the surface defect, layer inconsistencies, and support removal marks. Then you have to check it for dimensional accuracy. Measure critical dimension using the tool like caliper, micrometers, or coordinate measuring machine to compare with the design specification. So that is your post-print inspection. After that, if that means if your components are used for or if it is taking a certain load, you have to conduct a tensor and compression test or impact and hardness test. Okay, so that can be performed after the inspection. Okay, just to get confirmed that the printed parts can take the particular load whenever it is in working condition. Then we have surface finish and quality. Surface roughness measurement should be done using profilometers or similar to measure and quantify the surface of the roughness. In post processing, we have already seen the techniques like sanding, polishing, and chemical smoothing to improve the surface finish. So this quality check should be done. Then functional testing. If we are using this for the fit and assembly test, so we have to check the number of parts to be whether they are fitted correctly with each other. Operational testing, test parts under operational condition to verify they meet performance requirement. Okay, so if any movement is there in between them, so that must be checked. Okay, so that is part of the functional testing. Then defect analysis and feedback. Defect documentation. So document any defect found during the inspection and testing, noting the type, location, and potential causes. So that is defect documentation. Root cause analysis. Conduct root cause analysis to determine why defect occurred and implement a corrective action. If defects are there, again we have to go back to the 3D modeling. The first step, that is 3D modeling. Then the 3D printer software, that is we have to change the parameters. Okay, so that corrective action we have to take, and continuous improvement. So use feedback from the quality control process to enhance the future print design, material choices, and printing parameters. Okay, so this is done by the experience only. With the experience in 3D printing, you can you know how to design the model, and how to reduce the time of the printing, and how to save the material also. So this is all regarding the quality control and the inspection. Okay, so thank you very much.